This is section 2.7, part 1, and in this section we're going to continue to use the same formulas we have been using, except now we're going to draft diagrams that have more than one triangle connected to each other in a variety of ways. And make sure when you're doing your assignments you go back and you take a look at the steps that I've given you on the side. They're actually pretty helpful, and for most questions they follow this pattern, and you'll be able to use that to at least get you started or get you out of spots where you're having difficulties. So, first question, find the length of BC to the nearest tenth. Keep in mind that tenth is one decimal place for a final answer. So, draw a diagram. It's really important that when you're doing your textbook questions, you're actually redrawing the triangle that you see in the question in your notes. Since you're writing right on your sheet, you don't need to redraw this one exactly, but you are going to take it apart and draw it into two pieces. So first of all, take a look. You have two triangles. You have one here and you have one here. You want to first of all deal with the triangle that has two pieces of information, or two numbers. And you'll see that the triangle on the left, in this case, has an angle number and a side number. That means that that's the triangle with the most information, and we're going to deal with that one first of all. So the first thing I'm going to do is I'm going to redraw just that triangle just to keep things a little simpler. We have 26 degrees, we have 22.9, and this is A and B and D. And then we're going to use our usual steps. We're going to label our sides. This is the hypotenuse, this is the opposite, and this is the adjacent. Once you've done that, you're going to make the list, as I call it, and the list consists of two numbers, 22.9 and 26 in this case, and our question mark. And the question mark is what you're looking to find. Now, the 22.9 is the hypotenuse, the 26 is angle A. Now, what are you looking to find? You have a few things that aren't known. But what you really want to find is you want to find the side of this triangle, or the angle, perhaps, that is connected to the other triangle. If you go back up here, you'll notice that BD is a side that connects those two triangles, and it's the same length in both. So that's the side I want to find. Always the side that connects them or is the same in both. So we're going to find side BD, and that's going to be our opposite side. Taking a look at our information, which formula has a hypotenuse, an angle, and an opposite? Well, that's going to be our sine. Sine of angle A is equal to opposite over hypotenuse. The sine of 26 is going to be equal to x over 22.9. The sine of 26 in our calculator of 4 decimal places is 0.4384 is equal to x over 22.9. Our little mathematical trick that we like to use at this point is to put this guy over 1 and to cross multiply. Now remember, cross multiply means these two get multiplied together and they end up side by side, then the equal sign, then these two get multiplied together and end up side by side. So 22.9 times 0.4384. 1x is commonly just called x. We don't put the 1 usually in front of it. And to one decimal place, we get x is equal to 10.0. And I suppose I probably should have gone back and called this side x right here, instead of calling it BD. Now, you're done looking at the left triangle. Let's go to the other triangle now, and I'm going to redraw that one as well. So the other triangle's here, and what we know is that this is going to be a right angle. That is going to be 49 degrees. We now know that side x is 10 up here, which means in our little triangle over here, this is 10. Let's label our sides. This is the hypotenuse. This is the opposite, this is the adjacent. We'll do our variable list, and our list consists of two numbers and our question mark. What is it that we're looking for? The 10 is the opposite, the 49 is angle C in this case, then what are we looking for? Go back to your original question. Find the length of side BC. BC is the side between angle B and angle C, and it's this side right here. And since we've already used x, pick a different letter, different variable, and we'll call it y. So in our case, we're looking for the hypotenuse of our little triangle, which we've decided to call y. So what formula are we looking for? Let's look at our list. We have an opposite, an angle, and a hypotenuse. And again, in this situation, we're looking at sine then. Our formula for sine is the sine of A is equal to opposite over hypotenuse. It's going to be the sine of 49 degrees this time is equal to 10 over y. The sine of 49 is 0.7547 is equal to 10 over y. Use a little trick. Put that over 1. Cross multiply. This time these two will end up beside each other equals these two. So 0.7547y is equal to 1 times 10, which is just going to be 10. We're going to divide both sides by 0.7547. 0.7547. You can't see that. This is going to cross out. You're going to end up with y is equal to 13.3. Now, to answer your question correctly, let's make sure that we double check our side, go back up to your original top diagram. That is indeed side BC. And just to make sure we get our answer right, let's change that back into what it is, and that's side BC is 13.3.